In this short video, I'm going to show you how to use StatCrunch to estimate a population mean with a confidence interval. When we're working with means, we have two different ways that we can have the information. We can have summary data, and then we can also have the raw data. So first we're going to go through an example that uses summary data. So how much time do Americans spend eating and drinking? Suppose for a random sample of 1,001 Americans aged 15 and older, the mean amount of time spent eating or drinking per day was 1.22 hours, with a standard deviation of 0.65 hours. Calculate the 95% confidence interval estimate for the mean amount of time Americans 15 and older spend eating and drinking each day. So in StatCrunch, this is summary data. I'm going to go to Stat, and I don't know the population standard deviation, so I'm definitely using T-stats, and I've got one sample, and I've got summary data, because if you notice in the input screen here, I've got the sample mean, which was given to me as 1.22, and the standard deviation from the sample was given to me as 0.65, and my sample size was 1,001. And we want to do a 95% confidence interval, so similar to what we did before for proportions. We go down here under perform and we select confidence interval, this time for mu rather than for the population proportion. And make sure you've got the right confidence level there and compute. And so my confidence interval goes from 1 point, I'm going to go ahead and type it over here because in the next part of the question we're going to calculate the margin of error. So it goes from 1 point, when I round off, 1.180 up to 1.260. All right, so I'm 95% confident that the true mean amount of time the population mean amount of time Americans spend eating and drinking each day is between 1.18 hours and 1.26 hours. And then I want to calculate the margin of error, and I've got to find my calculator. Here it is. So I'm going to take the upper bound, which is 1.26, and I'm going to subtract the lower bound, which was 1.18, and I'm going to divide by 2. And so my margin of error in this case is 0.04. I'm just going to go ahead and type that over here. So ME equals 0.04. All right, now, the second way that you could have information is if you actually have the data. And so my second example, I have the data. Archaeologists have studied sizes of Egyptian skulls in an attempt to determine whether breeding occurred between different cultures. Listed below are widths in millimeters of skulls from 150 AD. And we want to calculate 99% confidence interval estimate for the mean width of the skull. So I went ahead in a StatCrunch spreadsheet and I put those numbers in here that were given to me in the problem. Now this time what I'm going to do is I'm going to go to Stat, T-stats, one sample, but now I have the data. And actually this is easier because all I have to do is select the column up here and then go down to the confidence interval portion, and this time they want a 99% confidence interval, so I'm going to change my confidence level to 0.99, and I get the confidence interval showed here. And notice again, now I didn't have the mean. If I wanted the mean, the point estimate, here it is here, 133.75, because that wasn't given in the problem because I was given the data rather than the summary data. And so my confidence interval here turns out to go from, 126.3, let's say, up to 126.3, up to 141.2. All right, and then down here I can calculate my margin of error as I've done before. Take my upper bound minus my lower bound and divide by 2. So I've got 141.2 minus 126.3 and divide by 2. And I got a margin of error of 7.45 for this interval. Notice this is a very small sample size, so we're not surprised that we have a margin of error which is fairly large.